Hello, we are going to do lesson 2 today from unit 1, which is on pages 9 through 11. So go ahead and get your workbook out and make sure you have it open to those pages. The very first thing I do want to talk to you about is the answers from last night's homework. You'll notice that only the answers are given here, none of the actual work. For you to get full credit for that, you do need to show the work. On number 1, the answer was 5. Remember, you have A and B because we have our right angle here. And so 3 and 4 are your legs. They're A and B, and we are trying to find C. Same thing on 2. We have A and B, but we don't have C. That's what we're solving for. And then on number 3, you'll see the answer is left as a radical. If you simplified that radical and did like 2 decimal places, that's okay. It does say to leave it exact, which would mean to leave it in the square root. But if you did simplify that, you'd get 3.87. All right, these were a tiny bit trickier, so I am going to look at them with you. Obviously, the answers aren't on here, but the big thing here is to actually understand them. So the very first part of number 7 says to rotate point A around the origin 90 degrees clockwise and label it as A prime. We're going to work a little bit more with the rules tomorrow in class, but if we're starting here at A, right here, and then we need to move 90 degrees clockwise, so a clock goes in this direction. So it needs to rotate 90 degrees. In class, I talk a lot about using and rotating your paper, getting that new coordinate, and then graphing it. So you'll see it's in the same place right here, A prime. If you turned your paper, that's where it would be. All right. B says reflect point A, so we're going back to the original, over the x-axis and label as A prime. So remember, this is the x-axis. So if it's 1 above, so we got to go 1 below to get our A prime right here. And then for the last one, for C, it says apply the rule x minus 2, y minus 5. So that is going to go left 2 and down 5. So from here, we want to go left 2 and down 5. And then that gives us a triple prime. Hopefully you tried that on 7. If you didn't, go ahead and pause the video and try it on 8. And then you can submit this. I do want to make sure that you are actually trying these problems. It is going to help you to try them. There are going to be some on your quiz. All right, looking at 8A. Reflect over the line y equals x. We haven't really done much reflecting over diagonals. But what you want to do is you want to count diagonally with the opposite slope of what this has. So I count across the boxes. So 1, 2, 3. And then we want to keep going in that same direction, but we need to go 3 again. 1, 2, 3. And then that gives us B prime. And then we want to look at letter B, rotate 180 degrees about the origin. So instead of 1 turn, that would actually be 2 turns. So if you take your paper and you turn it 290 degrees, which would be 180, you'll see that it ends up here. Write down those coordinates, put your paper back, and then graph it. And then C says translate it up 3 and right 7. So we want to go up 3, 1, 2, 3, and right 7. 1, 2, 3, 4, 5, 6, 7. And then that gives us B prime. Hopefully these make a decent amount of sense to you. We are going to work on this more in class tomorrow. We are going to talk a lot about perpendicular lines today in class for this lesson. So I do want to just refresh some things for you that you should know from previous math classes. Parallel lines are lines that have the same slope and never intersect when graphed. If you want to take notes on page 8 is a blank page in your book. And so it's a good place to kind of write these things down. So parallel lines, they have that same slope, but they have a different y-intercept, which is why they don't intersect. On the graph, the slope can always be found by using this formula. And this first one is if you are given points. And the second one is more if you have it on a graph. We've talked about it a little bit in class where it's always rise over run. That's always how you want to find slope when you have an actual graph. But when you're given 2 points, you want to calculate it by using that slope formula. So you're definitely going to Gonna want to have that written down for later. And the last thing that you should remember from a previous math class is that a right triangle has to have 3 sides to be a triangle, and then it has to have one angle that is 90 degrees. And we're going to talk about that. Most of the time, that is denoted with that little box in the corner. This is starting on page 9. It's the lesson 2, which is our lesson for today, called Is It Right? In Leaping Lizards, you probably thought a lot about perpendicular lines, particularly when rotating the lizard about a given center at 90-degree angle or reflecting a lizard across a line. We didn't really talk about it that way, but that is what this lesson brings in. In previous tasks, we have made the observation that parallel lines have the same slope. In this task, we will make the observation about slopes of perpendicular lines. Perhaps in Leaping Lizards, you used a protractor or some other tool or strategy to help you make a right angle. In this task, we consider how creating a right angle by attending to slopes on the coordinate grid. We begin by stating a fundamental idea for our work. Horizontal and vertical lines are perpendicular. It's very important to note that. Horizontal and vertical lines are perpendicular. They are always going to be perpendicular. On the grid at y equals 2 and x equals 3, they intersect to form 4 right angles. You do always want to remember that horizontal lines are always y equals, and vertical lines are always x equals. So, and it'll be like x equals a number, y equals a number, whatever number that may be. So, like this one is y equals 2, and this is x equals 3. Horizontal lines also have 0 slope, and vertical lines have no slope or undefined slope. All right, let's look at experiment 1, and hopefully you will understand how to do these steps. We're going to do 1 and 2 together. Then you are going to be asked to do 3 and 4 on your own and check your answers. Consider the points 2, 3, and 4, 7, and the line segment AB between them. What is the slope of this line segment? So we can already count slope because we can do rise over run. So we always want to start at the bottom and go to the top. So we rise 1, 2, 3, 4, and then we run 2, 1, 2. So M equals 4 over 2, which can be simplified to 2. Locate the third point C on the coordinate plane so that A, B, and C form the vertices of a right triangle with A and B as its hypotenuse. So what it wants us to do is find that point C that makes it so that we have a right triangle. And remember, we said that horizontal and vertical lines form a right or form a 90-degree angle. So if we erase the bumps where I counted slope, and if we look and see where we can make a point C to put our triangle, it's going to be right here at the bottom because it's going to be directly across from A. Draw that straight line a little bit better, and directly down from B, and it's where they intersect. So because those cause they're perpendicular lines, they make a right angle. This is now a right triangle. So point C is at 4, 3. Explain how you know the triangle you formed contains a right angle. I will say some of you may have seen that you can actually make that triangle also above, and it could have been up here. But I'm going to use this one on the bottom for my problem. It doesn't matter which one you use, whichever one you prefer is perfectly fine. So the next question, explain how you know that the triangle is formed contains a right angle. So what we can say is that AC has 0 slope and BC has no slope, and these are opposite reciprocals, which means they create a 90-degree angle. So zero slope is something like 0 over 4, and no slope would be something with 0 on the bottom, so like 4 over 0, which we know you can't divide by 0, which is why it's no slope. And opposite reciprocals really do have an opposite sign, but we'll talk about that in a minute. Looking at number 4, it says rotate the right triangle 90 degrees about the vertex point 2, 3. So 2, 3 is here at point A. Explain how you know you've rotated it 90 degrees. All right. So when it says 90 degrees and it doesn't give a direction, it always assumes counterclockwise. That's kind of the standard. So we want to rotate the whole thing 90 degrees about that point A. So point A is going to stay where it is. So if we notice from A to C goes 2 blocks. So if we rotate that 90 degrees counterclockwise, that is going to go straight up, and that is going to be C prime. If we look from C to B, that's a straight up and down line. So if we rotate it 90 degrees, it's going to become a horizontal line. We need to count how long it is. 1, 2, 3, 4 blocks. So it is going to still be 4 blocks long, and there is B prime. Now that we have B and C, A prime is actually still where A was because that's the point we rotated around. So AB, we can just connect them. So now we have our triangle rotated. And look at it and check and see, does it look like the triangle was rotated? The original one that I'm going to outline here in blue was rotated 90 degrees counterclockwise. If you turned your paper one sideways turn, would it look like the purple triangle? Yes, it would. The explanation we can use to say how we know we rotated it 90, our horizontal line, which was AC, became vertical. And the vertical line, might run out of space, CB became horizontal. Oh, that looks terrible. So because those changed, we can say that this is also a right angle. All right, last one says compare the slope of the hypotenuse of the rotated right triangle with the slope of the hypotenuse of the pre-image. What do you notice? So it wants us to compare the purple slope to the blue slope. So we already have the blue slope because we originally found it. So I'm going to write it in blue. But we need to find the purple slope. So remember, it's going to be rise over run. So we rise 2, but we run -4. It's negative because it's left. So we want to simplify that to get 1 over -2. And then we need to check and see if they're opposite reciprocals. So remember, opposite reciprocals have slopes. So you start out with the one that's a fraction. We flip it over. So then we get -2 over 1. And then you change the sign. So it becomes not -2, +2 over 1, which is the same thing as 2. And if they match, then these are perpendicular. Hopefully this makes sense. You are going to need to do these same 5 steps on the next ones. I will walk you through it so that hopefully you will do well on that one as well. All right, we are going to repeat the same steps on experiment 2 as we did on experiment 1. So step 1 is to find the segment or find the slope of the segment that's given. So find the slope of AB. So if we want to count rise over run, start at A, which is at the bottom. So rise 1 and run 3. So my slope is 1/3. So that was step 1. Find slope. Step 2 is to find a third point C that makes it a right triangle. So remember, we want to go directly down from B and directly across from A, and that's going to give us our point C. So C is going to be located at 5, 3. Then, so that was step 2. Step 3 is to explain how you know it is a right triangle. So AC has 0 slope and BC has no slope, and they are perpendicular, which means a right angle. That was step 3. Step 4 is to rotate the triangle. So I need to take that triangle, I'm going to rotate it about the vertex. So I'm going to rotate it about point A, so right here. And if I rotate it about point A, AC was horizontal. It now needs to be vertical, still having a length of 3. I'm trying to draw that line a little better. And then BC was vertical, so it needs to be horizontal, but it needs to be the same height, which is 1. So then this is C prime, this is B prime. A prime is right there on A, and then we can connect the two. I'm really bad at drawing these straight lines with these little tiny triangles. Okay, and we know that it's still a rotation. The reason's kind of the same. So 4 is just rotate the triangle. The reasons are still the same because the horizontal lines became vertical and the verticals became horizontal. And then we need to compare the slope. So now we need to find the slope for A prime, B prime. So if we're doing rise over run, I'm still going to start at A prime. So I rise 3 and run -1. So now I need to compare the slopes. So remember, so that was my slope for the blue triangle, A prime, B prime. So then I want to take my slope. So I'm going to take my original, flip it over, which gives me 3 over 1, and then change the sign, which makes it -3 over 1, which is equal to -3, which is exactly what we have here. So they are perpendicular slopes. The other way you'll see that written is this is the perpendicular sign, and sometimes you'll see me write that. All right, you do want to try experiment 3 and 4 on your own. At least find these things. You don't necessarily have to write out like for step 3, why, or step 4, kind of what you're doing, as long as you actually do the rotation. But make sure you find the points and the slopes and make sure they match like they're supposed to. Pause the video and work those out, and then hit play and make sure you check your work. All right, hopefully you paused your video and tried this problem. You'll see I already went ahead and worked it out for you. The slope of the original line, which I'm going to trace here in purple, I made that triangle purple, is 2 over 5. They're both positive because you're going up and right. Your point C is at 7, 3 because that's straight down from B and straight across from A. It is a right triangle because AC has 0 slope and BC has no slope. You rotate it 90 degrees clockwise about point A prime, about point A, which also is A prime. And then that gives us our pink triangle. You find the slope of A prime, B prime, and it becomes 5 over -2. Then you take your original, flip it over, it gives you 5 halves, and then you change the sign. It's -5 over 2, which matches what A prime, B prime is. So we know they're perpendicular, and we know we did it right. Go ahead and pause the video and try number 4 as well. All right, hopefully you tried number 4. The original slope of the line, which I'm going to trace over here in burgundy, is 3 over -2 because it does go left. The C point this time I actually did it above because when you rotated it, I didn't want to rotate it on top of the triangle. I thought that would be a little bit more confusing. Actually, it doesn't matter which way you do it. It would have been fine either way. So you could have done it at 0, 3 as well, and that would have been just as correct. Um, but I also wanted to show you that AC has no slope and BC has 0 slope this time because I did the triangle on top. So they kind of flip-flopped, rotated the triangle and did it in pink, and then found the slope of A prime, B prime, and it was 2/3. So I took the original, flipped it over, changed the sign, and it matches. So I know they're perpendicular, so I know I did it right. Your big takeaways from today should be that perpendicular lines they form right angles and they have opposite reciprocal slopes, and parallel lines have the same slope. There are times when lines just cross, but they are not perpendicular. They Just because lines cross does not always mean that they are perpendicular. You have to check those slopes and make sure that they are opposite reciprocals of each other for them to be perpendicular. Your homework for tonight is to make sure you finish yesterday's Leaping Lizards Desmos by 8 a.m. tomorrow morning. That is when I will be taking the grade for it. You have homework on pages 12, 13, and 14. It's not a ton of homework. Just go ahead and work through them. Remember, on 1 through 4, it is asking you to round to 2 decimal places if need be, and then start on your Unit 1 problem set in Delta Math. That looks terrible. Good luck, and if you need anything, don't hesitate to come to office hours.